All right, ladies and gentlemen, today we are talking about inverse relations and functions. Okay, we've discussed relations and functions already. Today we're mostly focusing on the inverse and what that is. If you think about inverse operations, that's a really good analogy. They undo each other. Inverse functions are the opposite. They undo each other. We're going to just look at a couple of pictures to start, and then we're going to do the math part. But these graphs right here are good pictures of inverse relations. Okay? They are the exact opposite, so they reflect over the line y equals x. I would write that down. When you see a graph, if you can draw the dotted line, the parent function of the linear family, y equals x, and it's a complete reflection, that means these two functions are inverses. Algebraically and mathematically, what happens is x and y switch. So if our first function here is y equals x squared minus 4, that's not that one, it's this one, y equals x squared minus 4, here's all our x and y values. Zoom in, and when you switch the 5 and negative 3, the 0 and the negative 2, it becomes this function, and you get this beautiful symmetry across the line y equals x. So these are inverse, but we have to be very careful. This is an inverse relation because it is not a function, okay? So what happens was when I made this relation, y equals x squared minus 4, that is a function. Its inverse is not. We'll talk more about that in a minute. Algebraically, what we're going to do and we did this a little bit in Algebra 2, we're going to switch x and y, then solve for y. So, for example, if I had this function a, f of x equals x minus 4, the way to do this is say, well, that's the same as y equals x minus 4. So first, switch x and y. X equals y minus 4. And then solve for y. Plus 4 x plus 4 equals y. This is our new equation, and in order to show that it is an inverse of this f, we would write f inverse of x, that's a tiny little negative 1 there, it's not an exponent, and write our new function, x plus 4. So these two algebraically are inverses. When you think about the graph of these functions, they're both linear. X minus 4 looks like this. X plus 4 looks like that. And here is our y equals x dotted line. Pretty good reflection. Because I sketched it, it's not exactly. If you were to use a graphing calculator or Desmos, it would look perfect. That's how we show it. So this is our inverse function. That is our original function. These are both functions. So it's good to go. All right. Now we're going to try a little bit different ones. B, f of x equals the square root of x minus 4. So again, this is like our y, and we're going to switch those two, making it x equals the square root of y minus 4. Now your algebra skills are going to have to come in handy here. How do I get rid of a square root? Square it. Square it. That goes away with that. We get x squared equals y minus 4. Add 4 on both sides. Y equals x squared plus 4. Okay? So our inverse function, f inverse of x, is equal to x squared plus 4. Now, watch how these compare. Our square root function shifted right 4 looks like this, right? Our inverse function is a parabola shifted up 4 that looks like this. So even though only part of our graph is the inverse reflection, these are still inverse functions because this part cannot exist down here. So therefore, we can still describe these as inverse functions. Okay? All right. Vice versa, we're going to jump to D. We're going to save C and E for later. They are completed on the online completed versions. You can see them right here. This is what you'll see online. But we're going to skip to D just for the sake of making this a shortish video. F of x equals negative 4x squared plus 8. So I'm going to make this my y and that my x. Negative 4y squared plus 8. I'm going to skip some algebra steps, so stay with me. Negative 4y squared equals x minus 8 on both sides. Divide both by negative 4 and we get x minus 8 over negative 4, we'll fix this in a minute, equals y squared. And then this is the new algebra step. Square root of both sides. Algebraically, you would have to put this plus or minus here. We'll come back to that in a minute. All right, now watch what I do here. I'm going to take this as negative 1/4 x plus 2. I just divided these pieces. And then I'm just going to write f inverse of x right here. There's my inverse function. This one's a little bit more complicated, so if you can get to that part right here, you're going to get lots of credit. This simplification, I just said 1 divided by negative 4th is negative 1/4 x. Negative 8 divided by negative 4 is positive 2. All right, so thinking about these other functions, we've got a shift down, vertical stretch, vertical reflection. Sorry, shift up 8. So it's going to go up to 8, be real skinny, and then flip. Like this. The inverse needs to be over here, making this type of shape. So we have a square root function. Negative 1/4 makes a horizontal reflection, so instead of going this way, it's going to go that way. The 1/4 is a horizontal stretch, so it's going to make it skinnier. And the plus 2 is shifted left 2. Oh, right, and then the 4 stretch. So it's going to look like this. Sorry, shifted right 2. Anyway, it's going to look like this. And again, if I covered up this part of my function, those would be perfect inverses, right? Right down the middle. So the plus or minus kind of gives me this piece right here. So what you need to understand is this is not a function by itself, but if I take off that, then it would be a function. It's kind of tricky to do, but if you can understand it, then that's good. It's not going to be very many points on your test, so ask questions about this in class for sure. All right, now to the next part, proving that two functions are inverses. Okay, sure, we can solve one for y and find it, but if we can't prove it, then it's going to be tricky. So what we're going to do is we are going to prove that two functions are inverses by using composition. So two functions, f of x and g of x, are inverses if f of g of x equals g of f of x equals x. Both of these pieces that we did last class must equal x. Okay? Let's see what that looks like. Example A. F of x is equal to 6 over x minus 4, and g of x is equal to 6 over x plus 4. So the first thing I'm going to find is f of g of x. That means I'm taking g, plugging it into f. So here's f. F is on the outside, 6 over blank minus 4. And what am I plugging in? G, 6 over x plus 4. It looks complicated, but if these things are inverses, they simplify much easier than you would think. The only thing I can do down here is combine like terms. Positive 4 and negative 4 go away. 6 over x. Keep, change to multiplication, flip your second fraction. Those go away, leaving me with x. So that's a keep, change, flip. Therefore, it equals x. Check. Now, that doesn't prove it enough. You have to prove g of f also equals x. So we're going to do the same thing. G, 6 over blank plus 4. Now, if they are true inverses, f is 6 over x minus 4, then they will simplify very easily. So what you do is you leave off that 4 for now, keep, change, flip this fraction, and you get 6 times x minus 4 over 6 plus 4. Those go away. And what happens to our negative 4 and our positive 4? Those also go away, leaving us with x. Check. We prove that f of g of x equals x, and g of f of x equals x. Thinking through this, the operations are the exact same in inverse in opposite order. This x is being subtracted by 4, then divided into 6. This x is being divided into 6, and then being added 4. Alright, let's look at one that doesn't work. I take that back. We're going to do one more example, and then we'll look at one that doesn't work. Alright, if f of x equals x squared plus 10, and g of x equals square root of x minus 10. Now do know that this one should say x is greater than or equal to 0. In order for these to be true inverses, we have to restrict the domain of this parabola so it's only the same half as this guy, okay? So we got to say x is greater than 0 so that those are actual true inverses. But the math, f of g of x, open up f, blank squared plus 10, plug in g, x squared of x minus 10. My squared and my square root goes away, leaving me with x minus 10 plus 10, minus 10 plus 10. Check. G of f of x, square root of blank minus 10, x squared plus 10. What happens to my 10s? They go away. Square root of x squared is x. Check. Alright, so that's a good situation. Let's take a look at a bad one. This is actually number 33 on your homework. It looks like, I have it pulled up right here, g of x is equal to the square root of x plus 8, and your minus 4 is on the outside. F of x is equal to x squared plus 8x plus 8, where x is greater than or equal to negative 4. So remember, this is just the restriction on the domain to make sure that this is the right half that matches with the square root function. Okay, that's all that means. So let's see what happens when I try to do f of g. Now remember, if I've got two x's, I've got to open up two spots. Something squared plus 8 times something plus 8. What is that something? It's my g, square root of x plus 8 minus 4. This one is square root of x plus 8 minus 4. Okay, I'm going to do the easy part first. 8 times square root of x plus 8, 8 square root of x plus 8. 8 times negative 4 is negative 32 plus 8. This is where it gets weird. Square root of x plus 8 minus 4 times square root of x plus 8 minus 4. FOIL. Square root of x plus 8 times square root of x plus 8 is just x plus 8. Square root of x plus 8 times negative 4 is negative 4 square root of x plus 8. Negative 4 times square root of x plus 8 is negative 4 times square root of x plus 8. Negative 4 times negative 4 is negative 16. Now, I got kind of shady there. These are all my terms I have left over, so I'm just going to combine like terms. Negative 4 square root of x plus 8, negative 4 square root of x plus 8 is positive 8 square root of x plus 8, so those all go away. Negative 16 and negative 32 and positive 8 and positive 8 makes negative 8 and 8 is 16, so those go away. Negative 32, and then my x is right there. Pretty sure I did that right. That negative 32 is not okay. So therefore, that is a no-go. We could stop right there, but I just want to show you what happens when I do g of f. Maybe they'll be a little bit simpler. So here's g, x plus 8, minus 4, and I'm going to plug in x squared plus 8x plus 8. So when I get this, I just combine like terms. X squared plus 8x plus 16 minus 4. This right here is a perfect square trinomial. If you factored that, you would get x plus 4, which is the same as x plus 4 squared. And when I have the square root of a square, it goes away. X plus 4 minus 4, boom, boom. That one equals x, which is good. But this one does not equal x. It equals x minus 32, so that's bad. Let me double check my work really quickly. X squared, square root of x times so square root of x times square root of x, x plus 8, minus 4, positive 16. Boom. There's my problem right there. But the only thing that changes, no, that changes everything. Shoot. So that actually does work. Anyway, that's what it would look like if it didn't work. It would get something other than x. But that one does work. Please come and see me in tutorials if you have any questions.